Sorry, I was having technical difficulty. So where was I? With the p-value. This is the next thing that we need to be working on. We're getting the right direction, knowing that if it's small, but then we get confused from there. So if the p-value is small, you reject the null hypothesis because it is such a small probability that if the null hypothesis was true, it rarely would happen that way. Okay, so we say that we reject it because there is evidence that says that we can reject the null hypothesis. And then, so that's you need three parts. You need to say why, you need to say that it is small or that it is large. You need to say whether you reject or fail to reject the null hypothesis. So if it's small, you reject. If it's larger than 0.05 or 0.1, then you fail to reject. Okay, and then the rest of this part follows it. So the rest of it is that you need to be in context with the problem. Okay, so small, you reject, and that you say that there is a possibility of difference, right? So they say that the change in work week did lead to a change in average driving mileage. It doesn't say a direction because our alternative hypothesis did not have a direction in it. Okay, so that's why that's what it is, okay? So then the rest of this, you should propose a course of action, but there wasn't enough information in there, so we don't necessarily need to do that, okay? So p-value small or large, reject or fail to reject, and then the third part is in context of the problem. Okay, a little bit more here. So for confidence intervals, to find the critical t value, this is what you would do. So inverse t, and then your area is the confidence interval. So 1 minus the confidence interval, right? And to that, you add, 1 minus the confidence interval divided by 2 plus whatever the confidence interval is. Okay, so for example, if it's a 90% confidence interval, you do 1 minus 0.9 because you change the confidence interval into a decimal, divide it in half, and you add it to 0.9, and that's what gets us to 0.95. And that's the number that goes right there. Okay, and the degrees of freedom comes from the problem. Okay, so maybe this is a way to help you remember what should go in for the area. Okay. All right, so next we're going to talk about effect size, and that's really where the confidence interval comes into play with this. So the question is, by how much on average might a change in work week schedule reduce the amount driven by workers? So same information here. This is the mean. This is the standard error. And the only difference is right here where we have to figure out what this t-value is. So I put it right here. The area is 0.975 because it's a 95% confidence interval. So 1 minus 0.95 divided by 2, and we add it to 0.95. And that's how we get 0.975. Okay. And then the margin of error is going to be that number times the standard error. So right here, the confidence interval is right here. Okay. All right. So with 95% confidence, I estimate that by switching to a 4-day work week, employees would drive an average of between 216 and 1,748 fewer miles per year. And then they try to fix this. With high gas prices, this could save a lot of money. Okay, so that's where that comes from. Okay, so 2 more things I wanted to show you as far as software results. With a printout, sometimes on the AP test, they will give you this kind of a picture, and then they will ask you to do the problem based on this. So I just want to go through this. So here are our 2 groups. Okay, we have and it could be called matched pair or paired T. So you need to look right here to determine that it is matched. Okay, the mean difference, that's your, this is going to be the mean of the difference and the standard error. So these would be the 2 values you would use to figure out what the T is. Okay, and then these 2 are for, because it's the upper and the lower, this is going to be your confidence interval. It tells you what N is, and the correlation, we don't necessarily need to know that right now. Okay, the paired T statistic is 7.15. I told you that it should be between -3 and 3. This is what it came out to with the computer printout, and it's way, way less than 0.001. So you would reject the null hypothesis because it is so tiny. They also give you all three possibilities, whether it's the absolute value, means that it's greater than or less than. So that's two-sided, okay, because of the absolute value. And then one direction is, it's greater than or less than, okay? All right. Okay, so here's another printout that they could give you. All right, so let's see, groups may have missing values. You don't need, you may not learn that from some packages. When I ran my data, it just tosses out the ones that don't have, I think I clicked a button and it tossed those out. Okay, here is the 95% confidence interval. It tells you the t-test. We get the exact same number that we got before. Okay, let's see. You may need to calculate n-1 for the degrees of freedom. Okay, they give you this superfluous numbers. So they give you extra things that you don't need, and that's what that means. So you have to kind of pull out what information you need. All right, so you're basically looking at this paired difference column is really what is important to you. Okay, and then that's it. Okay, that's the end of this second part.